Hey class, in today's lesson we're going to talk about standard deviation, which is found in section 11-6 of your book. Our objective is to find the standard deviation and variance of a set of values and to apply standard deviation and variance. Alright, so range and interquartile range are examples of measures of variation because they describe how the data in a data set are spread. Variance and standard deviation are measures showing how much data values deviate from the mean. The Greek letter sigma, which by the way, I'll draw that by the way because I couldn't get the symbol on here. So sigma represents standard deviation while sigma squared is variance. So variance and standard deviation. These are their symbols. All right, so to find the standard deviation, sigma, you need to follow these steps. So first we need to find the mean. Okay, and then we'll find the difference between each value, right? Each of the values that we're given minus that mean. And then we're going to square all of those differences. Then finally, we'll add them all up, divide them by the amount of numbers there are, and that will give us the variance. Then if we want to know the standard deviation, we take the square root of that number. Okay, so let's follow these steps on the next example. All right, so it says what are the mean, variance, and standard deviation of these values. Okay, the first thing you want to find is the mean. Okay, so that's x bar. So to find standard deviation, so to find the mean, we need to add these up in our calculator. So that'll be 6.9 plus 8.7 plus 7.6 plus 4.8 plus 9.0. If we add those all up, we get 37. And the amount of values that we have are 1, 2, 3, 4, 5. So 37 divided by 5 will give us 7.4. So 7.4 is our x bar. Okay. Now from there, we need to take each x value, so each of these values, and subtract 7.4. So subtract 7.4. And I'm going to do that for all of them, and then I'm just going to drop the values down. Okay, so by the way, this is x minus x bar. Okay, so 6.9 minus 7.4 gives us negative 0.5. 8.7 minus 7.4 gives us 1.3. 7.6 minus 7.4 is 0.2. 4.8 minus 7.4 gives us negative 2.6. And 9 minus 7.4 gives us 1.6. Okay, and then from there we need to square all those numbers. So this will be x minus x bar squared. So take each of those and square them. So that will be negative, and you need to be sure that if it's negative you need to put in parentheses. So negative 0.5 squared will give us 0.25. 1.3 squared gives us 1.69. 0.2 squared gives us 0.04. Negative 2.6 squared is 6.76. And then 1.6 squared gives us 2.56. Finally, we'll add up all those numbers and divide it by the total amount of values. So remember, our total amount of values are 1, 2, 3, 4, 5. We have 5 values. So add all these numbers together. And we'll get 0.25 plus 1.69 plus 0.04 plus 6.76 plus 2.56. And that's going to give us 11.3. And again, we need to divide that by 7 to get 1 point. We're going to, I divided by 7. I'm sorry. We're supposed to divide that by 5. Let me go back. So that's really 2.26. So divide that by 5, and we get 2.26. Now 2.26 is the variance. I lied. I'm still lying. No, I was right. The variance, which is sigma squared. Okay, so if we want to find the standard deviation, which is just sigma, we would take the square root of that number, and you will get 1.5. And now we're done. Okay, so let's go back from the top. At the very beginning, we found the mean. So add up all the numbers, divide by how many numbers there are, so we got 7.4. From there, we took each value and subtracted it from the mean. So that's x minus x bar. Once we got all of those values, we squared them. After we got all those values, we added them up and still divided once again by how many numbers there are, which is 5, and that gives you the variance. Then take the square root of that and it gives you standard deviation. So we're going to do this all over again in the try. Alright, so again we're going to find our x bar. And remember, that is the total amount of numbers divided by how many numbers there are. So let's go ahead and state that n equals 1, 2, 3, 4, 5, 6 values this time. So we're going to add 52 plus 63 plus 65 plus 77 plus 80 plus 82. And that's 419 divided by 6. That's going to give us, we're going to round to the nearest, let's make this to the nearest 10th. So this will be about 69.8. About 69.8. Okay, and then from there, each of these becomes x minus x bar. So we need to subtract all of them by 69.8. All right, so that's going to give us, for the first one, 52 minus 69.8 is negative 17.8. 63 minus 69.8 is going to give us negative 6.8. 65 minus 69.8 is going to give us negative 4.8. 77 minus 69.8 is 7.2. 80 minus 69.8 is 10.2. And 82 minus 69.8 is 12.2. Okay, then remember, from there we need to square all of them. Okay, so if we square all of them, that's going to be negative 17.8 squared is 316.84. Negative 6.8 squared is going to give us 46.24. Negative 4.8 squared is going to give us 23.04. 7.2 squared is going to give us 51.84. 10.2 squared is going to give us 104.04. And then 12.2 squared is going to give us 148.84. Now remember, at this point we're going to find the sum of all those values. So let's add them up. 316.84 plus 46.24 plus 23.04 plus 51.84 plus 104.04 plus 148.84. Okay, add up all those numbers, which is 690.84, and divide by how many numbers are our total again. So out of 6, if we divide by 6, we get 115.14. Okay, and this is our variance, or sigma squared. Okay, so to find standard deviation, which is the square root of that, that will give us about, I really should be saying about on those, that's about 10.73. And we are done. All right, so of course I wouldn't give you something this lengthy and so difficult without giving you an opportunity to figure out how to do it on a calculator. So let's go through this. It says the table displays a number of U.S. hurricanes, U.S. hurricane strikes by decade from the years 1851 to 2000. So it says what are the mean and standard deviation for this data set. All right, so all we're going to do is take these strikes. The decades, we don't need those numbers because that's just telling you the decades as far as listing it, but the strikes is the information that we want. So what we do is we go on our calculator and we press stat and enter, which would be stat and edit, okay? And then to enter, then we need to go ahead and in L1 start typing in the strikes. That's 19, 15, 20, 22, 21, 18, 21, 13, 19, 24, 17, 14, 12, 15, and 14. And I'm just going to go back and count to make sure I have all 15. And I do, okay? So now you go to Stat and go over to Calc and press Enter for first var stats or one var stats. And if it goes to your home screen, just press Enter again. And then it gives you all the information that you need. Okay, so it says what are the mean and standard deviation. Remember, mean is X bar, which in our case is going to be 17.6. And standard deviation, remember, is just sigma. And so sigma, and it may look like sigma x on your calculator. Okay, sigma would be let's say 3.5, because we're just going to round it to the nearest 10th. And that is it. All right, so let's try this again on the next one. Again, we're just going to type in these values into L1. So go to Stat and Edit. You may need to clear out your L1 if you already have numbers in there. And in this case, we are typing in the numbers, not the years, but the numbers. So that's 4, 4, 3, 11, 10, 3, 10, 8, 8, 9, 4, 7, 9, 14, and 5. Then we're going to go to Stat, Calc, go to first variable stats, and again, your mean, which is X bar, is equal to 7.3, and your standard deviation, which looks like standard deviation X or sigma X in your calculator, will be 3.2. All right, so we're going to keep going. All right, so it says use the U.S. hurricane strikes data from example 2. Within how many standard deviations from the mean do all the values fall? Okay, so here's a little bit of information. So a standard deviation kind of helps us to describe, and we'll start talking about it a little later, but it helps us figure out the percentage of your data that kind of varies from the mean, okay? And the standard deviation is what helps to describe that. So what we would do is from problem 2 with writing, not with writing, but with having all of our data, for the hurricane strikes, what we need to do is put all those values on a number line. All right, so let's say the smallest value, I believe, is 12, and the largest value is 24. So let's just create a number line from 12 to 24. In fact, 10 to 25 might work also. And by the way, if these numbers had been larger or a lot more distance between the numbers, you could have used increments. I just chose to go by ones. All right, so there's a 19, there's a 15, there's a 20, there's a 22, there's a 21, there's an 18, a 21, again, a 13, a 19, again, a 24, a 17, a 14, a 12, a 15, and a 14 again. All right, so after we've marked all these values, then we want to go ahead and start putting a little bit of extra information on here. So if you remember from before, the mean from this problem, or X bar, from this problem is 17.6. So 17.6 is kind of like our middle. So we're going to place a dot at about 17.6. That's really closer to 17.5, but you get the idea. Okay, so from there, to figure out how many standard deviations that the numbers fall within, you take that number, X bar, and either do plus or minus sigma, which is a standard deviation. And our standard deviation for this problem was 3.5. So for example, to find within one standard deviation, we would say 17.6 plus 3.5, and we would also do 17.6 minus 3.5. So let me throw that into the calculator. 17.6 minus 3.5 gives us 14.1, and then 17.6 plus 3.5 is 21.1. So then I would mark those off. So 14.1 is about here, and 21.1 is about here. Okay, we do not have all the information within one standard deviation. So let's check to see if it can fall within two standard deviations. So then what we would do essentially to do that is basically say 2 times that. So 17.6 plus 2 times 3.5, which we know is 7. And then 17.6 minus 2 times 3.5, which again, that's 7. So 17.6 plus 7 is going to give us 24.6. And 17.6 minus 7 is going to give us 10.6. So now we're going to go as low as 10.6, which is back here, and then 24.6, which is about here. Okay, now all of the values, all those x's, right, they all fall within two standard deviations. So to answer the question, how many standard deviations from the mean do all the values fall? All of the values fall within two standard deviations of the mean. All right, so we are done there. So let's keep going on to the try. All right, so on try 3, it says use the Atlantic Ocean hurricane data from try 2, and within how many standard deviations of the mean do the values fall? So that was the last one that we did on the calculator. So we should just be able to go back to stat, calc, first variable stats, because it should still be in there to remind us of our information. So all you really need is the X bar, which X bar is, let's say it's 7.3. I'm just going to round to the nearest tenth. And standard deviation is 3.2. Okay. Now again, we still need to list all those numbers so that we can see it all. And it looks like our smallest number is 3 and our largest number is 14. So I'm going to go from 0 to 15. All right, and then I'm going to start putting X's, kind of like doing a frequency table, not a frequency table, but basically just tallying the marks above the numbers. Here we go. Sorry, couldn't think of the vocabulary. All right, so 2 X's started off, or 2 4s. Then we have a 3, an 11, a 10, 3, 10. And again, I'm getting this data from try 2, so if you need to know what the data is, go back to try 2. Then I have 8, 8, 9, 4, oops, there's 4, 7, 9, 14, and 5. All right, now let's mark off our chart. So the mean is 7.3, so that's about here. So to find it within one standard deviation, I have to do 7.3 plus 3.2 and 7.3 minus 3.2. So 7.3 plus 3.2 gives us 10.5, and 7.3 minus 3.2 gives us 4.1. So from 4.1, which is about here, to 10.5, which is about here. That's not all my information. So then I need to do within two standard deviations. So that's 7.3 plus 2 times 3.2. And then 7.3 minus 2 times 3.2. So it's really 7.3 plus 6.4, which gives us 13.7. And again, 7.3 minus 6.4. And that's 0.9. So that's essentially all of them on the left. And then 13.7 is about here. And here's an issue. It's not going to pick up that last 14 if it's within two standard deviations. So our answer is actually going to be, because we don't even really need to do the work to be able to tell us, but it's going to fall within 3 standard deviations. So the values fall within 3 standard deviations. And guys, that is it. So if you have any questions, please be sure to come see me for tutoring.